Okay, guys. So we're jumping from, we just finished chapter 5. We are jumping to chapter 8.
What?
Yes. Chapter 6 we will come back to after this chapter. Chapter 6 deals with like cubed roots, fourth roots, fifth roots, and like switching between radical form and rational exponent form, like and back and forth and whatnot. That chapter gets a little tricky in and of itself. So we're going to wait on that chapter. Chapter 7 is logarithms, which obviously we are ahead of schedule. Yay! I'm so excited about that. Logarithms. You know that button on your calculator that says log? You ever see that button? Yeah, it's on there. It says log. My hope is we will get actually through that chapter. I have not gotten to the logarithm chapter since I taught the advanced version of Algebra 2 here at Penna. So, ever since they created intermediate, that kind of pulled out the kids that used to kind of slow this class down. Not to be rude, but math's not maybe their forte. So now that those lovely children have been moved out of this class, we can move faster, and we have been. You guys have been doing great. You're doing just fine. You totally shouldn't have. You should have been in this class last year. No. Yeah. So how many of you took intermediate? That is shocking to me that many of you took intermediate. Oh my gosh. I cannot. Seriously, looking around, some of you that raised your hand just now, like, that just floors me that you took intermediate.
It was just geometry.
Because you guys are like, some of you that raised your hands are like my top math students in here. That's funny. Christian? And they wouldn't switch you last year? Well, sometimes that does happen. Moving kids is hard because then that classes fill up. All right. Yeah. Yeah, you told me that. All right, so here we go, guys. So the reason I'm jumping to chapter 8, though, factoring is fresh in your mind, and we don't really touch factoring in chapter 6 or chapter 7. So if I went from 5 to 6 to 7 to 2 chapters of no factoring and then came back to this, where factoring is every day, every single problem, you'd be a little lost, right? So we're going to keep moving where the factoring is fresh in your mind so we do a little better with this, okay? So this chapter, we will not do the whole chapter. We're actually going to do 3 sections, 8.4, 8.5, 8.6. The rest of it, not that important in the grand scheme of life. So, according to your state standards for Algebra 2, you need 8.4, 8.5, 8.6. So that's what we're going to do, and then we're going to move on. Now, that being said, we're going to spend probably 2 days, at least 2 days on each section, because some of them are a little tricky. All right, so this chapter, though, is dealing with fractions. Yay! So 8.4 is just a single fraction, multiplying and dividing. The next section is adding and subtracting with like and unlike denominators. And then 8.6 is solving. So the first 2 sections, like for the first week and a half, we won't solve anything. Okay, we're just going to simplify. And then we'll get into solving afterwards. Okay, so for today, though, I just want to do simplifying and multiplying. We'll do dividing tomorrow. I actually was Cindy Lou Who one year on my Christmas card picture. My husband was the Grinch and I was Cindy Lou Who, and I had my hair all pulled up. My hair was a lot longer. I believe that. I literally put like a box on my head and like did my ponytail up over top of it. I'll have to bring it. Actually, I think the back of that Christmas card over there has a picture on it. I'll have to pull it out and show you. All right, anyway, back to math. Let's get through this. So first thing, we're just going to look at simplifying a single rational expression. I know fractions are a foreign concept to some of you, so this is why we kind of slow down a little bit here. So rational expression is just, we're going to do one fraction bar, and we're going to have stuff on top and bottom. Are you seeing where the factoring is going to come into play? Like you could just have, like 3x, like a monomial. This is a binomial. You got a trinomial down here. You got all kinds of stuff going on. So first thing we're going to focus on is how to simplify. In a simplified rational expression, the numerator and denominator will have no common factor other than plus or minus 1. So if I look at this, what would you tell me would cancel out on your fraction? Yeah, you would cancel the c's and tell me this is a over b. Okay? Now, the thing that gets people in trouble is what they start canceling out. They start canceling things that are not allowed to be canceled, and I'll explain that in a minute. So simplified versus not simplified. So going from here to the simplified answer, what did they cancel out? The 2's?
They canceled out the negative. Yeah, because it's negative plus 3 minus 3. They canceled out the. No.
They canceled out an x minus 2 with an x minus 2.
Oh, by the 2.
When you said 2's, I just heard 2's. The entire piece was canceled, right? Now look over here. Notice they didn't cancel out the x's. They didn't cancel out the 3's. Okay? Guys, when you're canceling things, if it is held with a plus or a minus, it's like it's got an imaginary force field around it holding those things together. You either take the whole thing or you don't take it at all. Okay? That is the hardest thing for people to kind of get in their head. If it's held with a plus or a minus, you cannot piece that out. You either take the whole thing or nothing at all. Okay? So if you look down here at the next one, x squared plus 4x plus 3 over x squared plus 4x plus 3. The same thing on top, same thing on bottom. Right, technically I could factor this if you really wanted to. X plus 3, x plus 1. Right, that would factor. If I think about it in factored form, then you're like, oh yeah, it's got a whole x plus 3 piece. It's got an x plus 1 piece. And if everything cancels, your answer is really just 1. Kind of think back, if I had 5 over 5, you wouldn't be like, oh, it cancels and it's nothing. 5 divided by 5 is it's 1. Yeah. So when everything cancels, your answer is just 1. It's really not bad. If you can keep in your head, if it's held with a plus or minus, I can't touch it, like, then this is really not that bad. 4x squared over 8x. Do you notice how there's no plus or minuses in this? So every piece is fair game. Yeah, I can divide top and bottom by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Yeah, I can take out an x from here, which leaves me with just 1x on the top. So 1x over 2. X over 2. Kinda. Yep. Yep. And we'll do lots of examples today to help cement this in your head as we go. Okay? So, next thing we need to talk about are restrictions. Now, your textbook, not that we ever actually see it or follow it, but your textbook does not teach restrictions until 8-6 when you get into solving. If I start teaching you solving and restrictions at the same time, it's a lot to take in. So I start teaching it to you now, just so you get used to it. So when we get to solving, you're like, oh yeah, no big deal, and you know what they are. Okay, so just kind of hang with me. I'm trying to teach it to you kind of spread out. So a rational expression in its simplified form. So you have original problem, you're going to simplify, so it'll look a little different. They must have the same domain in order to actually be equivalent. Do you know what letter domain stands for? You have domain and range. Domain stands for x. Range stands for your y values. So your x's, in other words, they need to be the same. So in other words, looking at these two, oh, those aren't simplified versions. Like for this example, if you would simplify this, right, you would have canceled these out, and you would have been left with x plus 3 over x minus 3. Can't cancel them, right, because they're held with a plus or minus. They're not the same. So when we're looking at this problem, I'll let you see the whole thing. This is the same as this. This is just simplified. Just like 2/4 is the same as half. It's just simplified, right? So the domain will include all real numbers except for numbers that make the denominator equal what? Look, 0. You cannot divide by 0, right? If your denominator of a fraction is 0, you can't do that. All right, so numbers that make the denominator equal 0, they're referred to as your restrictions. So they're like extra answers that might show up that actually don't work. So they'll put a 0 in the denominator, which is not allowed. Okay, so in this case, in this example, what would the restrictions be? What would x be that would put a 0 in the bottom of this?
What would x be?
What would 3? 3 and 2. We've been solving these things left and right? You can do that in your sleep probably by now. Right, so your restrictions would be x could not equal 3 or 2. come back to the problem. If x was a 3, you'd have 3 minus 3, which is 0, and then 0 times anything is 0. Put the 0 in the bottom, which you can't do that. Same thing with a 2. If I put a 2 in here, 2 minus 2 is 0. 0 times anything is 0. 0 in the bottom, can't do that. So you have to do your restrictions when we find these. I'm going to ask you to list them for me on the original problem. Because if you look at my simplified answer, which restriction would I not have found? I wouldn't have found the 2. And these have to have the same domain restrictions.
So it's kind of like,
They have to be the same in order for those to be
so it's kind of
congruent.
like proving method, where you have to have like two of your same answers to put them together.
Kinda. You could think of it that way. Yeah. So what would the restrictions be on this one? X would not be allowed to be what? What would make the denominator equal 0? 8 times negative 8 is negative 64. It's 0. 0. Right? 8 times 0 is 0. It's not plus or minus. It was being multiplied. It's kind of like baby brother. If your baby brother was an 8x, what would you tell me x equals? 0. We are finding what would the x be in the denominator that would make it a 0 down there. In other words, you're solving. Solve the bottom. Set them equal to 0 and solve. That's really what we're doing here. Right, for the restrictions. Because think about a fraction. You can't have a 0 in the denominator of a fraction. It's undefined. You can't do it. We're finding what can x not equal. Because then it would make a 0 in the bottom. Now guys, let me explain why I'm having us find this. When we get to 8, 6 and we're solving. Let's say I go through, I solve my whole problem, I get x equals 3. Is x allowed to be 3? No, because if x is 3, you would put a 0 in the denominator, which means that is undefined. You can't do that. So that's not necessarily you did something wrong, but that's just not a good answer. Maybe there is no solution. Or maybe you found like 3 and 7. Well, 7 would be good, 3 would be bad. Okay? They're called extraneous solutions. Sometimes when you solve, you get answers that really don't work. Yes? Yes, because x doesn't equal that. It's what it's not allowed to equal. This will come more naturally to you as we do more problems. Okay, I promise it will. All right, I will give you a flow chart as this chapter progresses. Sorry. As this chapter progresses, I'll give you guys a flow chart to help you keep track of all the steps for all of these. Sorry, my scarf gets caught on everything. All right, but for right now, I did not print that yet. I forgot. So for today, one fraction. If you're dealing with just one fraction, step by step, you're going to factor everything you can first, if it does. You're going to do your restrictions. So what can x not equal that would put a 0 in the bottom? And then cancel anything you can, right? Simplifying that fraction. Those are your step-by-steps. Hang with me. I promise you will get there. I promise. All right, so number 1. Step 1 says to factor. Can I factor something if there's no plus or minus signs in it? No. Right? I mean, like pulling out a GCF, or you can't. You can't actually factor something out if there's no plus or minuses. All right, so I can't factor. What would my restriction be? You would tell me x cannot be what? What would put a 0 in the bottom? A 0. Because 0 to the 5th power is 0. 0 times 20 is 0. It'd put a 0 in the denominator. So if you have a monomial, one term with an x on it, x can't be 0. Okay? All right, and then it says to cancel. What could you cancel, or what could you simplify? That's funny, you guys. Okay, I know what you're saying. All right, so I could divide them both by 5. So that would make that a 3. Divide that by 5. That's a 4. And then an x squared. So that x squared would be gone, and this would become x to the 3rd. So I have 3 over 4x cubed. Anything common still sitting in here? So you know you did good. Yep. $65. Is that okay? I never give you guys that much. You know I don't give you that much homework. No, I wouldn't do that to you. I'm not that unrealistic. All right, number 2. So step 1 says to factor. If they're monomials, there's no factoring. There's no factoring. Step 2 is your restrictions. Now notice in the denominator you have 2 variables. X and Y, neither one can equal 0. Because again, they're all just being multiplied. So being multiplied by 0, you can't have a 0 in there. Hold that thought to number 3. Okay. All right, and then the third step says to cancel or simplify anything that you can here. So you can divide both numbers by -6. 24 divided by -6 is -4. -6 divided by -6, 1. What about the x's? Can I do anything with those? I can do an x squared. Good. So x squared, that's going to make this just an x on the top and a y on the bottom. Take out 2 from the top, leave 1 on there. So I have a -4 in x, and that's all over y, or 1y. You're like, wait, this is too easy, right? Like, no, I'm serious. You're talking number 3? Okay, guys, take a look at number 3. The comment was, can I cancel the x squared? If it's held with a plus or minus sign, you either take the whole thing or you don't touch it. What was step 1? Just factor. Can you factor those? Yeah. How's the top factor? We know it's x and x plus minus 4 and 2. So we can, guys, step 1 is to factor. Factor everything you can. I can factor the top. Can you factor the bottom? Mm-hmm. On the bottom, we know it's x and x. Both minus 3 and 2. Guys, that bottom of that fraction, you're going to hear me refer to that as the dreaded 6-5 combo. Because what happens is options for 6 is 1 and 6 or 2 and 3. Both can give you a 5. Depends on your signs. And people mess those up all the time. Yep. See, and that happens a lot. So that's that dreaded 6-5 combo. You're like, yeah, it works, but you got to really watch your signs. Yeah. All right. So once we factor, what was step 2? Restrictions. So this is where we're looking at the denominator. X is not allowed to be what? 3 and 2. So the question earlier was, is one of your restrictions always going to be 0? No. If you have like baby brother out front with an X, then yeah, you're going to have a 0. Oh, okay. Restrictions right here. I'm only looking at denominator. That's the bottom. Okay. Yes, they can be negative. Now, guys, the reason we only, again, let's go back to why we're only looking at the denominator. What if I have 0 divided by 7? Is that okay? What's 0 divided by 7? That's 0. What if I have 7 divided by 0? Grab your calculator, type in 7 divided by 0. You can't. You ever ask Siri, what's 0 divided by 0? Have I played that for you guys? Yeah. Yeah. Yeah, it doesn't make sense. And Cookie Monster is sad because he has no friends. That is my third step, but yes. All right, so then, guys, that was my restrictions. Third step is cancel. I can cancel x minus 2's. X plus 4 over x minus 3. Ooh, can I cancel those x's? No. If they're held with a plus or minus, you don't touch them. Okay? You either take the whole thing or nothing at all. Yes? You pretty much solved the bottom. Nope, solved the bottom. Solve the bottom, right? Last chapter, if you factored, you would tell me x is 3 and 2. Just solve them. Yeah, just solve the bottom. So those should come as second nature to you guys by now, right? We've been doing that forever. All right, number 4. Hey guys, number 4. What's step 1? Factor. So let's factor everything we can. How does the top factor? Now, some of you will like this chapter better than others because you're fast at factoring. If you are slow and tedious when it comes to factoring, you're going to hate this chapter because we factor every problem. Yeah. Good. X plus 4 and x minus 4? No. All right, and then what's step 2? Restrictions. X is not allowed to equal plus or minus 4. You guys okay if I'm lazy? And again, I'm just solving the bottom, right? Just keep going with it. You guys are so used to doing that at this point. Yep, that's how I'm getting my restrictions. Right, because the only where I care about a 0 falling is in the denominator. Good, and I can cancel the x plus 4s. Can I cancel the x's? And there will be someone in here. I don't know who it's going to be. But somebody in here is going to cancel those x's and tell me your answer is negative 1/4. I will yell at you. I may publicly ridicule you in class. I'm going to call you out. Don't do it. I know, we should come up with something. We'll think about it. Yes, I'll post this later today.
No, I mean like.
Yes, they would be. All right, okay, let's take a look at number 5. Does anything jump at you on number 5? The top is out of order. Well, the bottom we can see the factoring we're going on there, right? But the top is what I was looking at. What's wrong with the top? It's not in standard form. Guys, you must rewrite everything in standard form. Now that negative sign was in front of the 4x, it stays in front of the 4x. That 12 was positive, it stays positive. I'm just rewriting it in the right order. I can take out the 4. The very first rule of factoring. Take out your GCS. So I'm going to take out it. Yes, if that first one's negative, what was the first thing we learned? You take it out. The directions say step 1, factor. What's the first thing you do in factoring? You take out a GCS. All right, and then the bottom? Good. What's step 2? Restrictions. What can x not equal? Why can x not be plus or minus 3? It put a 0 on the bottom. I want to make sure you're understanding why we're doing this. Okay? Anything cancel? Good. So negative 4 over x plus 3. I taught this in Algebra 1 when I taught in Finley.
How long did you teach it?
10 years.
10 years.
Mm-hmm. This is my 5th year here.
Wait, so you were in your like early 20s when you started teaching one.
I was 21. I graduated college in 3 years. My first year teaching, I was 21. I had a student who was 21. Mm-hmm. In a freshman level math class. And then like he only stayed like part of the year, and then like he just stopped coming. And then like a month later, he was arrested for murder.
Oh my God.
And I had him in class. His name was Michael Kitchen. I will never forget that. Michael Kitchen. He meant his last name was Kitchen. He did not mean the murder part.
No.
His last name was Kitchen. But I will never forget that. I will never forget that child. White. He was a bit off. He was always very nice to me, but he was a little off.
That's how the kids used to when they
Common Core was not out yet. I'll be honest, not much has changed. High school math, not a lot's changed in Common Core. That's what really changed, yeah. All right. What? Yes. Oh. I didn't tell you her name.
Well, this dude's a criminal, so.
His uncle is my neighbor.
What? That's a weird random connection. And the fact that you knew that? How did you know that? That's weird. That was a long time ago. That was 15 years ago.
So maybe he out, maybe he didn't vote. Maybe he didn't.
There he be. We got a weird connection. Okay, here we go. Number 6. I got 3x squared. Good. Adrian, you with me? We're taking out a 3x squared. You good? Okay. So 3x plus 2. You have like terms sitting on the bottom. 3x squared plus 12x squared. It's 15x squared. You have like terms sitting here. So that's 15x squared plus 9x. And now I can take out a 3x. So I would have 5x plus 3. That's not my next step. What's my next step? Restrictions. X cannot equal 0. Just one. If that was an x squared, there would be 2 of them. And negative 3 over 5.
Wait.
Solve this. The bottoms. Right? That would be a 0, and then that would be negative 3 over 5. Yeah, always the denominator when we're doing restrictions. Oh, this is that's technically still the same denominator. I just made it something I can actually, yeah. All right. Does anything cancel? Very nice. See the 3x and 3x squared out here? Those are not connected by plus or minus. But if they're not connected with a plus or minus, you can piece them out. You can piece them out. So the 3's will cancel. And I can cancel one of the x's, so you'd still have one up top. So I have x, and then 3x plus 2 over 5x plus 3. And I am done there. So, yeah, you really got to stop and think, is it connected with a plus or minus? Right, the 3x plus 2, those are a piece together. I can't touch that. But the 3x out in front and the 3x squared out in front, those are attached. They're being multiplied by that parenthesis, not added or subtracted. Yep. Math always comes full circle, doesn't it? All right, that's my fancy technical term right there. Yes, at the Walmarts. Or at Major. Major. Okay, Rogers. That's great. All right, so we're going to move into multiplying. You could have 2 fractions, you could have 3, you could have 4, doesn't matter. Typically we have 2, but don't panic if you see 3 or more. What's the only difference between the steps we just did? Smoosh. Smoosh. Isn't that fun to say? Smoosh.
I saw that earlier and I started doing it.
You do, right? It's just a funny word. The reason I tell you to smoosh is I don't want you to distribute this all back together again. Yes. Now, if you just have like a 3 and a 5, you would multiply that to 15. But if I have like 3x plus 5 and 7x minus 2, don't distribute and multiply those back together. Don't do that. So you just kind of smoosh them all together into one fraction. Smoosh.
So like, is it like smooshing it together?
No.
Like as well,
That would be adding like terms.
Yeah, no.
I don't want you to do the math. I just want you to smoosh them all together in one fraction and call it a day.
Like, you know, like we get all those really big problems and then they become like really tiny. You just.
Yeah, some of these problems kind of do that to people. Like they start off huge and you go all the way down to that and your answer is 1. And you're like, seriously? Like I did all that work and I get a 1 out of all of this? I get excited when that happens. Other people get real mad because they're like, really? That's it? Okay, so here we go. So this is multiplication. I know they do. How do you know that's multiplication? Yeah, there's a dot. I have people every year go, how do I know if it's multiplication? There's a dot. Not a division sign, not a plus, not a minus, right? I'll let you be that person. Okay, so what is step 1? It just says factor. So that means I can factor anything and everything I can. Okay? So how about on the top? How's the top factor? There we go. Does the bottom factor 2x squared? No, that's just 2x squared. Oh, we're doing all of them. Yeah, I just work, you know, left to right. All right, how about 2x plus 8? Okay, got a 2. Don't forget those GCS. People forget those all the time. So then I have x plus 4. On the bottom? Thank you. X plus 4, x plus 3. Do you love the look on my face? And you're like, no, you can't. I'm like, really? Really? We should be beyond that by now. All right, so step 1 said to factor. We went through every single piece, factored everything we could. Step 2 was restrictions. Now, I have more denominator pieces. Should I look at all of them? Yeah, all your denominators. So what would this one give you as a restriction? 0. You can write 2 zeros. But honestly, it doesn't matter. If you tell me x cannot equal 0, do you have to tell me twice? I mean, some of you have to tell like 7 times, but I should just have to tell you once. X can't be 0. -4 and -3. Good. Those are my restrictions. I don't. If you need to run to the restroom, you can. I know, right? I had a bunch. Jonas was sneezing and snotting all over everything for forever. Jeez, Jonas. Jonas, you're supposed to smile at that. All right. So guys, when I'm looking at this, the next step is cancel. Now, any top, any bottom. It does not matter if one's in this fraction and one's in this fraction. Any top, any bottom. Good. The x plus 3s, one top and one bottom, I can put them together. X plus 4, they're on the same fraction. That's okay. Any top, any bottom. Good. My 2's. You see how this 2 is not attached by adding or subtracting? Either is this one. Those can be gone too. Guys. Yes. When you think you're done canceling out what you can, smoosh what you got left together into one big fraction. So what is left on top? An x minus 2. And all you have left is an x squared. Can I cancel this x with one of these? That's held. Now, guys, one thing that might help some of you to see that, anytime something has a plus or minus sign, if you throw parentheses around it, sometimes it helps people to see like, oh, that's a whole group. Like I can't just take part of that. Okay? I think these are fun. I like these problems. I'm weird though, I get it. I'm a nerd. All right, number 2. I can factor. How do you factor the top? Why not? It's just x. Top? Good. How's that back table? We interrupting your conversation today?
No, we're trying to figure out why they're putting TVs all on. It's DVT thinks that they're broadcasting in the one, even though we're complaining about not being able to see, so they started to put TVs up so everyone can see.
Yeah, I just saw yesterday they were putting them up. I'm like, that's interesting.
That's somebody more.
I think they're going to also put more announcements and stuff on them too, which is funny to me because they had big old Jumbotron in the comments. All right, so we did step 1, Hey, we got a cool building that like has up to date technology and cool stuff. So just enjoy it. Restrictions. Right? We don't have to do that here, which is really nice. Yep, 0 and -3. All right, talk to me, Dakota. GCF is 6. GCF? Yes. Basic math's hard. I know.
Actually, I couldn't figure out what 6. I was trying to figure out how you find base 3.
All right, are we okay on restrictions? Just the denominators, 0 and -3. Hey, guys, take a chill. I want to make sure I don't lose anybody here. All right, Tegan, what'd you say? Yeah, I can cancel an x plus 3.
Can't you take out the x?
And I can take out this x with this x.
And then you smoosh.
And then I smoosh. And again, hold on. Somebody said it. Sam, was that you? What'd you say? What about the 3? Mm-hmm. 3 divided by 3 is 6 divided by 3. Yeah. On the top, I have an x minus 3, and on the bottom, I just have, what'd you? Now, what happens a lot of times is people might miss that 3 and the 6. So let me show you what would have happened. You would have had a 3 and an x minus 3, and on the bottom, you would have had a 6. And then I hope you look at what you write down. And a lot of kids I don't think do. But like, if I look at this, you see a 3 and a 6 there? Hopefully that stands out to you. Then like, oh wait, I can go further and turn it into this. Okay? So once you smoosh it together, look at what you got, because sometimes you miss things, and that happens. Oh, like down here? If that had been a 4, I'd have just sat it out in front. I don't ever distribute them. That's what I don't want you to do. That's why it says smoosh and not multiply. Because I don't want you to distribute. Simplest form is considered factored form. So leave them in factored form. Yep. All right, guys, let's go through this. Please do not shout everything out at once. Let's make sure everybody's okay. So on the top, taking out a 2. On the bottom, that's difference of squares, x plus 4, x minus 4. Oh, that's a weird looking 4. On the top, x plus 4, x plus 1. And on the bottom, x plus 4, x plus 4. All right, step 2 is restrictions. So x is not allowed to be plus or minus 4. That's it. All right, and then we can cancel. Any top with any bottom. Not 2 bottoms. So x plus 4 I can cancel. I can cancel an x minus 4. These 2, they're both on the bottom. I can't cancel those, and I saw a couple of you did. Has to be a top and a bottom. Now, I could have canceled this one with this one. It would have been fine, but you'd still had one over there. So on the top, for the smoosh step, I have a 2. I have an x plus 1. And I say smoosh because I do not want you to distribute that. And then I have x plus 4. I'm lazy. I'm going to write squared. Because I have 2 of them, right? There's 2 of them over there. You can write them both out if you want. I'm just lazy. Yeah, 2 on the bottom, they don't cancel. It has to be a top and a bottom. You okay? Good? Tara, you all right? Okay. Number 4. Isn't that penguin cute? He's so cute. Penguin. All right, so number 4, what do I do first? A factor. You said that so excitedly. A factor. How's the top factor?
I was trying to figure out what this was.
Can you imagine if I taught like that? Did you guys love my class then? So what do I do with the bottom? I can't even do it. That's just x plus 2. That's just not my personality. I can't do that. How about the top? Very good. Those are my favorite. X plus 6, x minus 6. And on the bottom, oh, it's a 6, 5 combo. Good. Because my last one's negative, so my signs have to be different. So make sure you're watching that. All right. Restrictions. X is not allowed to equal. Negative 6. So negative 2, 1, negative 6. Just solving all the bottoms, that tells you what x is not allowed to be. Why is x not allowed to be that? And make a 0 where? In the bottom, which we cannot divide by 0. All right. No. All right, next part. Yay, it's a fun part. What cancels? That it? Smoosh. What do I got on the top to smoosh together? X minus 2, x minus 6. He said that super fast. And on the bottom? Ooh, can I cancel these x's and those 2's? You're going to get annoyed by me because I'm going to ask that all the time. Because you know what? Somebody in here is going to do it. Who's it going to be? What? Real quick, guys, on this one, why would I throw this one on there? It's not a fraction. How do you make it a fraction? Yeah, put it over 1. But what else is wrong with it? Do you see an equal sign? Yeah, you can't do that. You can't do that. No, no, no. That's which is why we talk about these. You can't do that. All right, so guys, if it's not a fraction, put it over 1. Look at that. Now it's a fraction. But what else is wrong with it with the way it's sitting? What's wrong with this? It's not in standard form. That should be negative 10x plus 15. Guys, things aren't going to work out right if you don't put them in standard form. You're going to have sign issues. Okay, now are we good? Ready to start? That's where the problem put it. I didn't do it. The problem did it. So on the top, I have a 4. How do you factor the bottom? Oh, that's a harder one, isn't it? So 2x and x. What are your signs? Plus and minus? 1 and 3 and 1? My signs are backwards. Negative 3. Why am I erasing that? Plus 1. So negative 3 plus, yeah, that works. So yeah, all those guess and check factoring, the harder ones, they will show up again. All right, on the top, negative 5. So 2x minus 3. And just a 1 on the bottom. Ta-da! Lots of factoring, isn't that fun? Restrictions. Does that give me a restriction? Would it give you an answer? Is there an X there? No. Come on, guys. You're getting rusty on me. We just took a test yesterday. On the 4th page. Like front, back, front, back. I grade 1 page at a time because I memorize the answers. I can grade faster. Otherwise, I'm flipping my answer key and flipping your test. That's why I'm putting it. That's just too much. Yeah, I grade 1 page at a time. Okay, so where are we at now? I can cancel 2x minus 3. And that's it. So here's where people make the biggest mistake of them all. What's on the top? Which would give you what? Negative 20. What do you think people tell me? What'd you say? They tell me negative 1. What's this? What's that big giant dot we had a conversation about? Right, I say smoosh except for the fact of just plain old numbers. So yeah. So that's negative 20. And then x plus 1. You can put them on there if you want, but not really necessary.
What's 4 times negative 5?
Yeah, it's still there. I didn't cancel that, so it's still part of my answer. Are we okay here? Other questions? You got it? What about that one? Put it over 1. It's not a fraction, make it a fraction. And? All right, here we go, guys. Let's go through the last one, see how we did. Take out a GCF, 3x. So x plus 1. Take out a 2, 3x plus 1. And x plus 1. All right, so there it was factored. Step 2 is your restrictions. X is not allowed to be, does this give me anything? No. Negative 1/3 and negative 1. And then I can cancel top and bottom. So x plus 1, 3x plus 1. Now, when I smoosh together a 3x and a 2, do I actually multiply them or do I put a plus sign in between them? Where'd the plus sign come from? It's 6x. I don't want you to distribute. That's what I don't want you to do. It's a multiplication problem. Yep. It's just 6x. If you want 6x over 1, you can, but it's just not necessary. Okay? We good? Yes?